Hi everyone, welcome to week 16 for junior cycle ordinary level. So today we're going to be going through some transformations and angles. So we're going to be going through some different types of notation and theory, and then we'll look at some exam questions and solutions. So the first thing there is a ray is a line that extends from a point called a vertex to infinity in one direction. So you can see here that this is going to be the vertex, this is the point, and the ray extends out from the point to infinity, which means it continues on. The next part, an angle occurs in between two rays. So an angle in between these two rays would be this angle here, and I'm going to call that angle x. The notation A followed by B, and you use this kind of a bracket followed by this kind of a bracket, should be used to describe the ray with vertex A, so the point A, through B. So you can see that the ray is going through B and it's continuing on to infinity, and you use the notation as shown to demonstrate that. Okay, so angle notation should be read in an anti-clockwise direction with the vertex of the angle in the middle. So this is indicated by drawing an arrow or an anti-clockwise arrow at the angle. So you can see here the arrow is going in an anti-clockwise direction, and this is the angle ABC or CBA. So the drawing is always going in an anti-clockwise direction when you're talking about an angle. And then the following diagram shows the correct notation for the angles in a triangle ABC. So the first angle you see there is the angle BAC. So we're concerned with the letter in the middle. So it's the angle A. So the angle going from B to A to C in an anti-clockwise direction. If we look at this angle here, so the angle ACB, and it's going in an anti-clockwise direction. And as you can see again, it's the middle letter we're concerned with, which matches angle A. Then finally, we have the angle CBA. So this is the angle B we're looking for, and again, it's going in an anti-clockwise direction. So we're going to look at the different types of angles now. The following diagram shows a straight angle and a right angle. Intuitively, a right angle is half the measure of a straight angle. So we know that a straight angle is 180 degrees, and we know that a right angle is 90 degrees. Now you might be asked this, say, in an exam situation to label the different types of angles. So an acute angle is less than a right angle. We know that a right angle is 90 degrees, so an acute angle is less than 90 degrees. The next one, an obtuse angle, is greater than a right angle but less than a straight angle. So an obtuse angle is greater than a right angle, so it's greater than 90 degrees. But less than 180. And then a reflex angle is greater than a straight angle. So if it's greater than a straight angle, it must be greater than 180 degrees. Now if we were to label these three angles that are shown here, so this first one is going to be an acute angle because that's quite obviously less than 90 degrees. Oops. So it's an acute angle. Then we have the next one, which is an obtuse angle, so it's greater than 90 but less than 180. And finally, we have a reflex angle, which is going to be greater than a straight angle, so greater than 180. In degree measure, we say that a straight angle is 180 degrees, where the symbol, so you can see the degree symbol there, stands for degrees. This also means that 1 degree is 1 out of 180 of a straight angle. So we're going to look at a theorem now. So supplementary and vertically opposite angles. So the first theorem there, so the theorem states that vertically opposite angles have the same measure. So what we're saying here is this angle with two lines is the same as this angle with two lines, and this angle here with one line is the same as the angle that's vertically opposite with one angle, or one line, sorry. So we can use the fact that a straight angle is 180 degrees to prove this theorem. So we know that the angle AXC is 180 degrees. So that's a straight angle. So the angle AXC is 180 degrees. Then if we look at the next line here, so the angle AXB plus the angle BXC is 180 degrees. So this means the angle AXB and the angle BXC, we call them supplementary angles, and this means that they add up to 180 degrees. The angles BXC and CXD are also supplementary since they also add to 180 degrees. So now we have the angle AXB plus the angle BXC is equal to 180 degrees, and that's the same as saying the angle BXC plus the angle CXD is also 180 degrees. So this means that opposite angles are equal, i.e. the angle AXB is equal to the angle CXD. And you can see it quite clearly on the diagram there. The angle with two markings is vertically opposite this angle here with two markings, they're equal. And this angle with one marking is vertically opposite this angle with one marking, and they are also equal. So we're going to look at an example now. In the diagram below, what are the measures of the angles AXD, DXC, and CXB? So first of all, the angle AXD is going to be this angle here. The angle DXC is going to be this angle here. And the angle CXB is going to be this angle here. So for the solution, vertically opposite angles are equal. So this must mean that this angle here is equal to this angle here. So it's going to be 50 degrees. So the angle DXC is 50 degrees. So I'm just going to draw an arrow there. So the angle DXC is equal to 50 degrees. And the reason is because they're vertically opposite. And then we know that the angles AXD, which is this angle here, and DXA, and the angle DXA, they are complementary angles since they are on a straight line. So we know from this, the angle AXD plus the angle DXA is 180 degrees. We also know that the angle AXD plus 50 degrees is equal to 180 degrees. So this full angle here is 180 degrees, which must mean that the angle AXD, which is this angle here, is 130 degrees because it's 180 degrees minus 50. I'm going to just write this in brackets. So 180 take away 50. Finally, since vertically opposite angles are equal, the angle DXC is 50 degrees. We figured that out first. We also figured out that the angle AXD is 130 degrees. And the last one we need to figure out is this angle here, which is the angle CXB. That must be 130 degrees as well because it's vertically opposite this angle. So it's 130 degrees. So now we're going to go to some exam questions. So the first one I've pulled here is from 2012 and it's question 9. So 4 angles are shown below. Write in the space below each diagram whether the angle is straight, acute, obtuse, right, or reflex. So this first one here, this is greater than 90 degrees but less than 180. So that must mean that this is obtuse. And I'm just going to write the reason in here as well. So it's greater than 90 degrees. So greater than 90 degrees but less than 180, which is what an obtuse angle is. This angle here, the second one, is a right angle and it's denoted by this here. So that is a right angle and it's 90 degrees. So we're just going to write that in, it's 90 degrees. Then we have the third one. So the third one is going to be a reflex angle. And a reflex angle is greater than 180 degrees. And I'll write that above, so it's greater than 180 degrees. And then finally, this one is less than 90, so it's called an acute angle. So it's less than 90 degrees. So if we go on to part B, in the diagram below, L1, what this sign means is L1 is parallel to L2, which means that these lines, I'm just going to draw over it, L1, see with the arrow here, is parallel to L2, so they're never going to meet. These lines are never going to meet. Write the measure of each angle shown by an empty box into the diagram without using a protractor. Okay, well first of all, this angle here is vertically opposite this angle here. and we know that that one is 70 degrees, which means this one must be 70 degrees. Now, we need to find what this angle is. We know that this whole angle is 180. So 180 minus this angle here, which is 70, will give us what that angle is. 180 minus 70 is 110 degrees. So we're going to write that in. So this one is 110 degrees. Now, because these lines are parallel, it's nearly like an identical image down here. So this angle here is the same as this angle up here, so that's going to be 70 degrees. This angle down here is going to be the same as this angle up here, so that's 110 degrees. And then this angle, which we haven't dealt with, is vertically opposite this angle here, which means that this is also 110 degrees. I think that's the end of that question. It is. So we'll go on to the next one. The next one I have is, sorry, now zoom out, 2014 question 9. Okay, so question 9, use a protractor to measure the angles ABC and the angle DEF. So the angle ABC is this angle here. So if you use a protractor, so I can't use a protractor here on the screen, but you put the flat line of the protractor along the line BC and you measure the angle, and you should get a value of ABC to be 49 degrees. The next one, DEF, so that's this angle here. Again, you're going to put the protractor down on the line EF and measure the angle as the arc goes out to D, and the angle DEF is 66 degrees, so that's what you should be getting on your protractor. On to part B. The four angles M, N, O and P are shown in the diagrams below. Starting with the smallest, arrange the four angles in order of magnitude. Okay, well the smallest angle there is going to be angle O, so this angle here, so that's the smallest, so it's going to go O first. The next biggest one is going to be the right angle here, which is N, so that's 90 degrees, so we're going to put N in the next box. The next biggest angle is going to be M, which is this angle here, so we're going to put M in next. And then finally, the biggest angle is this angle here, P, which goes all the way back. So that's going to be P in the last box. And I think that's it for that one. It is. So the next one I have is 2015 paper 2, question 7. Okay, so question 7. Ida draws a sketch of the triangle shown. The lengths of the sides are 4 centimeters, 6 centimeters, and 8 centimeters. So the first question there is, what type of triangle has Ida sketched, and put a tick in the correct box. Now, if it's equilateral, I'm just going to write this down. Equilateral means that all of the sides are equal. So it's definitely not that, because we know that all sides are actually different. If it's scalene, it means that all sides are different. And if it's an isosceles, then it means that only two of the sides are the same. And if we look at that triangle, we see that there's a length of 4 centimeters, 6 centimeters, and 8 centimeters. So all of the sides are different, which means that it is a scalene triangle. The next part of the question is to construct Ida's triangle in the box below. So I'm going to show you what it should look like using your protractor and compass. Sorry, just your compass actually for this, because it's a triangle. So what you're going to do is you're going to measure 8 centimeters. You can see on her triangle she's 8 centimeters. So you're going to get your ruler and you're going to measure a length of 8 centimeters, like so. So the base of 8 centimeters. Then what you're going to do is you're going to get your compass and measure 4 centimeters on the compass. Put the pin of the compass here, and you're going to create an arc which will look something like this. Then what you're going to do is get your compass and measure a length of 6. So I'm looking at this side now. You're going to put the needle of the compass here, and you're going to create your other arc with that 6 centimeters on your compass to look something like this. When you've created your arc, you're going to join up your two sides of the triangle like so. Now you obviously use a ruler for this. So with that, you need to show your constructions. So it'll be better when you actually do it on paper, but you need to show those constructions of the arcs that are made, and your construction lines need to be shown clearly. So I'm just going to put in the length as well. So that'll be 6 centimeters, and then the last one is 4 centimeters. Okay, measure the biggest angle in your triangle from part B and write the size of this angle into the box below, correct to the nearest degree. Now if we look at our triangle there, the biggest angle is this one here. So you're going to get your protractor and measure that angle. When you measure that angle, it should be roughly 104 or 105 degrees. Okay, so we're on to 2013 paper 2. Okay, so for this question, question 9, draw 2 axes of symmetry on the regular pentagon shown in the diagram below. So the axis of symmetry, I always like to think if you were to fold it over, that would be even on both sides. So the first axis of symmetry is straight down the middle like so. So you draw your line with your ruler, obviously. And then there's one other axis of symmetry on that pentagon, and it's going to go roughly here. So you've got 2 axes of symmetry. So then it asks you, what is the total number of lines of symmetry of a regular pentagon? So a regular pentagon has 5 lines of symmetry, hence the name pentagon, so 5. And then we have to do transformation here. So complete the image of the pentagon under a central symmetry in the origin. Okay, so we're given an image there. You can see a pentagon drawn, and we have to map that image through central symmetry, so in the origin, which is the point here. So what you would need to do is measure the distance from this point here to this point here in the middle, and we measure the same distance again from the middle to this point here. So it's going to be the same distance you're measuring each time. And then what we do is we measure the distance, I'm going to use a different color here, from this point here to the origin, and then we'd measure that distance again, which would match up here. So once you have that, you can actually draw your pentagon as a mirror image. So it's going to look something like this. And again, this will be more accurate, obviously, when you're drawing your own pentagon with your ruler. So it's going to look something like this. And that's through central symmetry in the origin. And that's the end of that paper. So we're on to 2017 paper 2 now. Okay, so question 1 from 2017. The table below shows diagrams of a number of shapes. The lengths of some of the sides are marked. Fill in the table below to show the number of axes of symmetry of each shape. So the square there is going to have 4 axes of symmetry, and I'm actually going to mark it in the diagram as well. So that will be the first one. This will be the second one. This would be the third one. And then this would be the fourth one. So you've got 4 axes of symmetry there in a square. So then we're on to an isosceles triangle. How many axes of symmetry has an isosceles triangle? And the answer here is actually only 1. So the axis of symmetry is going to be straight down the middle like so. Then we have a rectangle. So a rectangle is going to have 2 axes of symmetry, and I'll draw them in now as well. So the axis of symmetry going straight through the middle like so, and also the axis of symmetry going down as well. And then finally a parallelogram. So the angles are not 90 degrees, so it's telling you there the angles are not 90 in this case. So you can't actually, if you were to fold that over, there wouldn't be any way you could fold that would give you that would make it fold evenly. So a parallelogram actually has no axis of symmetry. Okay, so I think I have another question here. So the next one is 2011 paper 2, question 11. Okay, so the question says the diagram below shows a triangle A on the coordinate plane and its image under a number of transformations. So we can see that A is labelled there. So there's your triangle, and then its image under a number of transformations. So we're given 3 vertices here as well. So the point -4, 3, the point -2, 5, and the point -1, 1. So write down the coordinates of the images of the vertices of A under each of the transformations listed below. So the first one there is axial symmetry in the y-axis. So when it's reflected in the y-axis, so this is our y-axis here, the tall one. So this triangle here is going to be the one that's reflected in the y-axis. So we need to write in the point. So this point here is the point 1, 1. This point here is the point 2, 5. And this point here is the point 4, 3. So that's that first one done. The next one, it's asking for central symmetry in the point 0, 0. So it's going through central symmetry. So that's going to be this triangle here. So we need to write down the points. So this point here is the point 1, minus 1. This point here is the point 2, minus 5. And finally, this point here is the point 4, minus 3. And then finally, it's asking us axial symmetry in the x-axis. So it's when it's reflected in the x-axis, it's going to be this triangle here, because it's reflected in the x-axis. That means it's flipped down onto the axis below. So this point here is the point minus 1, minus 1. Then the next point, which is this point here, is going to be minus 4, minus 3. And then finally, this point here is going to be the point minus 2, minus 5. And I think that's that question done. It is, yeah. So we'll do one more. So this question is actually from 2015. And it's paper 2. So the first question there, it says to calculate the size of the angle marked P in the right angled triangle below. So we're told first of all that that angle is 22 degrees, this angle here. Now if it's a right angle, if this is a right angle, that must mean that that's 90 degrees. So we can actually figure out what P is. So we know that the total amount of degrees in a triangle is 180. So it's going to be 180, take away these two angles added together. So 90 plus 22. That's 112. So 180 degrees minus 112. Put that straight into the calculator and you'll get 68 degrees. So the angle P is 68 degrees. Now the next question is draw the image of the triangle below under axial symmetry in the line K. So axial symmetry means you're reflecting it through this line K. So if we look at, we're going to reflect this point, and this point. So we'll look at this one first. So we've 1, 2 boxes to the line K. So if we count out 1, 2 boxes, this is going to be the reflection of the point. Then if we look at this point, we can count 1, 2 boxes to the line K. We do the same here again, count 1, 2 boxes, that's going to be that point reflected. Then finally, we're going to look at the last point here, which is this point. So 1, 2, 3, 4, 5, 6, 7 boxes to the line K. So we're going to count 7 boxes, 1, 2, 3, 4, 5, 6, 7, and that's our reflected point. So now we have our 3 points. We're just going to join them up. And obviously you use a ruler for this. And that is our triangle under axial symmetry in the line K. So I think I actually have one more question to do with you before we finish up. I'll just scroll down here. So the next one is actually from 2017. And it's question 7, paper 2. So the diagram shows 2 line segments. On the diagram above, write the letter A in an acute angle. Now remember, acute angle is less than 90 degrees. So we need to find an angle that's less than 90 degrees. Well, this angle here is definitely less than 90, so we can label that angle A. On the diagram above, write the letter O for obtuse angle. So obtuse angle, remember this means greater than 90 but less than 180. So greater than 90 but less than 180. So that's going to be this angle here. So that's the angle O. And then On the diagram below, it shows a parallelogram. One of the sides has been extended. The sizes of some of the angles are marked. Now it asks us to find the size of the angle F, so that's this angle here, the angle G, which is this angle here, and the angle H here without measuring, so it means without using a protractor. Now the angle F is actually an alternate angle to this angle here, which is 45 degrees. So because of that, we can say that the angle F is 45 degrees. The angle G, which is here, is an alternate angle to this angle here, which is 25 degrees. So the angle G is 25 degrees. And then finally, for the angle H, we need to get what angle H is without measuring. Well, we've figured out that F is 45. We have figured out that G is 25. So we could actually figure out what that third angle is. I'm just going to call it X. So if we wanted to find out what X was, it would be 180 degrees minus 25 plus 45. So that would be 180 degrees minus 70 degrees. That would give us 110. So if this angle here is 110 degrees, and we know that a straight angle, or this straight angle here, is 180, we can get H by taking 110, so 180 degrees minus 110 degrees. And that'll give us the remaining angle, which is H. So H is going to be 70 degrees. And I think that is it. Yeah, that's the final question. So I'm going to attach some extra video tutorials and extra links that you should follow, and I'll put it in the chat. And I'd highly recommend that you do follow them and just follow up with some extra questions as well. And I will speak to you next week.